Hello students, good day all. Today in this session we are going to learn about the continuation of waves and the essential condition for the formation of beats and the graphical methods, experimental demonstration of beats in sound, how the apparent frequency when the source which is moves towards the stationary observer. These and all elaborately we will see. Beats. When two sound waves of different frequencies traveling in the same path, in the same direction, it is in the medium of superpose upon each other means the intensity of the resultant sound will be get rise or fall alternatively with the time. So, these periodic vibrations in the intensity of sound is caused by the superposition of two waves of slightly different frequencies, which it has means we can say that is a beats, right? Now, the essential condition for the formation of the beat, for beats it need to be audible one. We need a proper audible beat. So, the difference in the frequency of the two waves, two sound waves should not be exceed the 10 decibel. Okay, if the difference is more than 10 means, we shall hear more than 10 beats per second. But due to the persistence of hearing, our ear is not able to distinguish between the two sounds or separated if the time travels between them is less than 1/10th of a second means. So the beats here will not be distinct if the number of beats produced per second. If suppose more than 10 means. Got it? So that only we are planning that the audible beat should not be exceed the 10 decibel. Right? And also you can see what we said about the beat means the one rise and the one fall of the intensity which getting constitute one beat. So the number of beats which is produced per second we can call the beat frequency. Got it? So the formation of beats by graphical method. So you are seeing on the screen two different the graphical method of the formation of beat. See that A1, the full line curve is the displacement time curve. Or we have taken the wave frequency is mu1, right? And the dashed curve is for the wave of the frequency mu2, the dashed curve one, right? So the V1, you may observe that the mu1 which is slightly greater than mu2. So the first wave is slightly smaller than the second one. If suppose at t time, t1 we have taken the time means the two waves will be meet in the same pace. So they reinforce to produce maximum sound intensity. With the passage of time, the pace difference between the two waves will get increased. And so that only the two curves gradually get more and more. Right? So time t2, the two waves are in exactly opposite pace. So this happens when one wave gains half a vibration over other. Now they produces minimum sound intensity. Now we can notice that the pace difference goes on decreasing with the time, right? So at the time t3, one wave gains one full vibration. The two waves are again in the same pace. So it's produced maximum intensity, right? It's going in that way only. So the resultant wave will be obtaining by the algebraic sum of all the displacements of the two waves. If you have taken means the full line curve which you are seeing on the screen, the second diagram will interpret, right? So the dashed, the envelopes above and below, it shows how the amplitude and the resultant wave varies with time. That beautifully we can see through the dashed envelope which is C. So the time interval from T1 to T3 is 1 beat period. Because during the intervals only 1 beat will form. The beat is formed during that intervals. So moreover, during the time intervals, the first wave completes mu plus 1. So it's getting oscillations. While the second wave completes mu oscillations. So what will happen? The beat frequency which is equal to the difference in the frequencies of the two superposition waves. Got it, children? That formation of the beat, how it is interpreted through the graphical representation. The experimental demonstration of beats in sound. See, you are seeing on the screen the diagram that is mount two tuning forks of A and B of exactly the same frequency of on the two sound boxes. It is placed with their open end of the facing each other. Now you are striking a little wax, that is, it may be stick with that. Now you are slightly reduce its frequency. Now set the two frequency, that is the tuning forks, into the vibrations. The two tuning forks will produce sound waves in a different frequencies. See, the intensity of the resulting sound will increase and decreasing periodically with the time. So we can easily, we can hear the beats here, right? So the apparent frequency when the source moves towards the stationary observer. See the diagram. We are taking the source S, which is moving with the speed Vs towards an observer. It is towards an observer which is moving, right? Who is at rest. If V, that is the frequency, mu is the frequency of the vibration, then it sends out the sound waves with the speed V at the regular intervals of time period T, which is equal to what? 1 by mu, right? Now, T, suppose at T which is equal to time which is equal to 0 we have taken here. Now, what will happen to the source? The source is at the distance L from the observer, so that it emits compression pulse. So it reaches the observer at the time T1 which is equal to L by V, right? Distance by the speed. So T1 which is equal to L by V. After some time, T, suppose we have taken which is equal to T, capital T. Then what will happen to the source? It will be moves, the source will be emit the next compression pulse after the time. So that the source has moved a distance Vs, the T towards the observer, and is now the distance is what? L minus Vst, right? So this is L minus Vst from the observer. So the second compression pulse reaches the observer. So at that time T2 which is equal to what we have taken? T2 which is equal to T plus L minus Vst by V. Now we need to know about the time intervals between the two successive compression pulse on the period. So the time period we have taken T dash here. So which is equal to what? You have to take it T2 minus T1. The differences between these two time period when you have taken, you will get the time period value, right? So T2 minus T1 which is equal to capital T plus L minus Vs into T by V minus L by V. By simplifying this, we will get V minus Vs by V into T, right? And now the apparent frequency of the sound as we are hearing by the observer is mu dash which is equal to 1 by T dash. So mu dash which is equal to 1 by T dash, so that by applying the value V by V minus Vs minus 1 by T, or V dash, the apparent frequency which is equal to V by V minus Vs into V, right? So this is, we can say, the apparent frequency mu dash. So mu dash which is equal to V by V minus Vs into mu. So this is the sound, sometimes it will be appears to increase when the source which is moves toward the stationary observer. Right. Yes, students. So far we have learnt about beats graphical method of bead and the condition, essential condition of the formation of bead. These and all we have studied. Thank you, children.